Alright, students, today we're going to talk about chemical weathering processes. And whenever you think about chemical weathering processes, you must always take into consideration that there are in fact three very distinctive chemical components, or chemical substances rather, which will be very, very important in terms of the breaking down of rocks by obviously chemical means. Alright, and we know for sure those three main influences, right, would be associated with oxygen, water, and acids. All right, so these three are in fact very, very important. Now, there are five major chemical weathering processes associated with chemical weathering. All right, of course, that's kind of redundant. Yes, sorry about that. But these five processes are carbonation, oxidation, hydration, hydrolysis, and solution. All right. Now, students, carbonation, right? This three term, carbonation, right? Carbonation is in fact a chemical weathering process whereby naturally occurring rainwater, right, basically is in fact capable of dissolving carbon dioxide, which is already naturally existing in the environment. Now, carbon dioxide plus rainwater, when they are mixed together, they create an acid known as carbonic acid. And carbonic acid, right, is naturally occurring in rainwater. Carbonic acid is very influential in terms of its caustic ability, in terms of breaking down chemically limestone as well as sandstone structures. These type of rocks basically are much more susceptible to this particular process, primarily because they are in fact made up of calcium bicarbonate. Oh, sorry, calcium carbonate components. All right, and that is actually quite pertinent. Why? Because the carbonic acid is that chemical substance, which is in the form of an acid, of course, which is often in solution, which also dissolves, right, these particular calcium carbonate components of limestone. Now, whenever we are looking at the process of carbonation, we should also take into consideration the process of solution. So, in the same breath, all right, we'll be talking about solution as well. Why? Because solution refers to soluble minerals and salts, all right, and other soluble chemical components which can be actually dissolved or mixed properly with water. All right, it can be flowing streams, it can be in the form of rainwater. It doesn't matter how the water is, once it's mixed properly. And rocks, which contain minerals and salts, are easily susceptible to the process of solution. All right, these salts basically form a very distinctive structure of certain rocks. And once this salt is somewhat extracted into the ambient environment, which is the water, it will tend to reduce the integrity, will break down the structure of that particular rock. So that rock will eventually be subjected to further disintegration. All right, and in this case, it will be chemical disintegration. Why? Because solution involves a solvent, right, which is in the form of water, and the actual substrate, which is the salt or the minerals, can in fact be easily dissolved. All right, now the third process of chemical weathering is that of hydration. Now, if I am actually sorry for the blurry image here, unfortunately, this is the best image I could actually get. But hydration is, in fact, the concept or the chemical weathering process where rocks tend to absorb moisture. And class, when it absorbs moisture, when rocks absorb moisture, what happens is that the pressure, the internal osmotic pressure within these rocks tend to expand, tend to increase. And in doing so, given the fact that rocks are solid in nature, they will eventually tend to break apart and develop fractures of or lines of weaknesses on their surfaces. All right. Now, if you look carefully, assume this is a rock structure here, right? And we have the influence of rainfall, which will actually impact upon the surface of this particular rock. And the rainfall, this rock actually tend to absorb, all right, some of this moisture. Now, as the rocks absorb moisture, all right, there's a significant amount of moisture or water inside this particular rock. And eventually this seam system, basically what it does, it will tend to exert an outward pressure. All right, the pressure pushes apart. The internal pressure or the internal osmotic pressure, all right, pushes apart on the outer structures of the rocks. All right, and this is important. All right, so this moisture actually it exerts an internal osmotic pressure. Sorry about my crap of an narrative. So it actually exerts an internal osmotic pressure, and by in doing so, we must bear in mind that these rocks will tend to develop little weaknesses or fractures by the increase of the internal pressure within the rock structures. And as time progresses, this rock will tend to what? Break apart. You will see pieces being broken off from the edges of these rocks because they expanded because of the internal osmotic pressure within the rock itself. All right. Now, the other process of chemical weathering processes is that of hydrolysis. Hydro is associated with moisture or water. Lysis is in fact a process which is in fact associated with disassociation or breaking apart of components. Primarily, we are referring to the molecules of compounds or the molecules of chemical substances disassociating themselves, all right, and allowing that level of rebonding. All right, imagine you have a rock which basically disassociates chemically, and those same molecules are allowed to react with the other materials that exist. Okay, students, so look at this carefully, right? Now, this is carbon dioxide in the atmosphere, as we indicated earlier when we were talking about carbonation. Carbon dioxide in the atmosphere, the formula is CO2. Water is H2O, all right? So carbon dioxide, when mixed with water, creates what we call carbonic acid, all right? Now, this carbonic acid is H2CO3. This carbonic acid now is capable of reacting with calcite, and this is what you call a carbonate mineral, what you call CaCO3 or CaCO3. I mean, I just pronounce it there, right? So calcite or this carbonate mineral, right, which is found in limestone and whatnot, CaCO3 is now able to react with rainwater, which contains carbonic acid. This carbonic acid, basically, the calcium will disassociate from the CO2. You will also have carbon monoxide, maybe also oxygen, and these molecular substances will actually tend to break apart. Right? For the hydrogen atoms or the hydrogen molecules really will disassociate. The oxygen molecules will tend to disassociate. The calcium molecule will tend to disassociate. And what happens is that they create what we call bicarbonate as well as calcium ions. As you can see, this calcium becomes disassociated from the calcite construct or the carbonate form. And the calcium is actually present in a different form. It is actually disassociated from the entire structure. All right. Whereas that you have the bicarbonate here created when you have the two hydrogen molecules reacting with the CO3 here, basically. So that is actually something which shows how the molecular constructs, right, of the substances, the chemical components can be disintegrated, disassociated, and also allowed and given the ability to readjust and recombine in a different form. All right, so technically, this disassociation, this chemical disassociation of the calcite or the calcium carbonate, you could actually see the disassociation of the calcium ion by itself. And these components are rebonded to create bicarbonate. Imagine that. All right. All right. Now, last but not least, I would like to talk about oxidation. All right. Oxidation is, in fact, listen to the term oxy. All right. You can automatically know fully well that you have oxygen involved. Oxidation is a process whereby rocks which contain iron, right, or I should say iron-bearing rocks, they are able to interact with the oxygen in the atmosphere as well as moisture. All right. Now, when oxygen reacts with rocks which contain iron, it produces what you call oxides, right? OXIDES. Now, oxides basically they possess a kind of reddish brown coloration, as you can see here. These rocks are in fact becoming oxidized because they contain iron first and foremost. And what happens is that the oxygen in the atmosphere and also the moisture basically facilitate the chemical weathering processes. So this is actually an effect. This coloration here, this reddish brown coloration, is an effect associated with the process of chemical weathering, specifically oxidation. All right. Now, class, I mentioned two factors there. I mentioned oxygen, right, which is obviously O2, and I also mentioned water. Now, if you have these two parameters, water is actually H2O. Now, if you have these two factors together, right, the abundance of water and the abundance of oxygen, just like a metal stool, right, if it is exposed to like rainwater and it's also exposed to the ambient environment where you have oxygen, this particular metal will tend to rust. Rust has a kind of reddish brown coloration. Now, typically, rust is essentially the formation of what we call oxides, all right, on the surface of the metal. Where do we get these metals? These metals are in fact extracted from deep within the Earth's surface, within the rocks. And within rocks, we actually extract iron ore, right, to process and to create iron or other forms of metals and stuff like that, steel and all these things, all right? And as such, the oxides themselves are associated with the reaction with water and oxygen. What reacts with water and oxygen? The actual ion, the ionic components, the components of iron within the rocks itself. Now, why did I mention water? We understand oxygen is involved, but water, the chemical composition of water is H2O. All right? Water actually has oxygen in it. This O is actually associated with oxygen. It has two molecules of hydrogen and also one molecule of oxygen. All right, so oxygen is also present in water. Keep that in mind for me, right? All right, so students, in a nutshell, this is essentially what chemical weathering processes are associated with. We must bear in mind that all these processes occur at different rates, of course, depending upon the nature of the rocks and the location as well. I hope this was informative. Any questions you have, feel free to let me know. All right, you can also peruse the video again, look back. Feel free to ask any questions. All right, students, you all keep good. Bye.